Hello, my friends. We are back to finish this lesson on parametrics. I hope you understood the first part because we are going to do some more. A little review here I think would be helpful. So, we talk about the velocity. Now we're going to find the velocity at a different time, pi over 2. Now you know cosine pi over 2 is 0, so the x velocity is 2, and 5 sine pi over 2 is 5. So we have a y velocity of 5. Now, let me tell you, on the free response questions, they're always going to be calculator questions, and you're never going to get numbers as nice as these. But I want to show you some things, so I made a problem with some nice numbers, so that's where we can talk about them and have a little more clarity. But when you're going to do the problems on the assignment, on the free response questions, then expect the numbers all going to be bad. They're going to be ugly. And that's okay, is how it works. So we said before, if I want the magnitude of the velocity at t equals pi over 2, then that is going to be the Pythagorean theorem with the 2 squared and the 5 squared and the square root. And that's a square root of 29, and that's about the 5.4. I don't want to write 3 decimal places. We don't need them. So what I know about this guy running around is that at t equals pi over 2, he's got the velocity 2 to the right because it's a positive 2. If the x velocity is a negative 2, then we know he's moving to the left. His y velocity is a positive 5, so we know he's going up. If his y velocity was negative 5, we would know he would go down. So he is going up and to the right, and his speed is 5.4 or square root of 29. So that is the speed problem from last time. What is next? Well, if you remember some things from last year, one problem was to find the total distance traveled by a particle in a given time. Now you think for a minute, what is that formula? I hope you got it. I will be very disappointed with you if you do not. To find the total distance, we're going to integrate the absolute value of the velocity with respect to time between the two times that we wanted. Well, in the calculus AB, you put your velocity equation in the absolute values in the integral, and it's a piece of cake. In this class, it's a little messy, so let's take a look. We have to integrate the speed. But the speed is not just one equation, the speed is two equations, and this is our problem. So I'm going to take x prime, x velocity, squared, and the y prime is the y velocity squared, and I'm going to square root it. All this goes in the big integral, and you're going to use the f in int to get the answer. It's a messy, you got the parentheses everywhere, but you can do it, you as a smart kid. So this is total distance in parametric. You got to memorize that, but if you think Pythagorean theorem, then you're not going to have a problem. All right, what else we got? Well, we might want to find the slope at a given time on the graph. Slope don't change what it is. Slope is always dy over dx. But you notice dy over dx don't have no t's in it. So we got to put the t's in somehow. Well, it just so happens with the notation, this is a y prime of t over x prime of t. So if we want to do the problem we're working, at pi over 2, dy over dx, t equals pi over 2. The y prime at pi over 2 was 5, and the x prime was 2. If they give you the velocity functions at the beginning of the problem, all you got to do is plug in the value because you already got that y prime and x prime. You don't have to do any derivative or integral. You plug in the value, you get the numbers for those, and you stack them up. That is the slope. So you're always going to write it like this and get the good points out of it. We got one more thing we got to look at. If they start us with velocity and they tell us a position, how do we find another position? Well, oh, it is not hard. It is what we did last year, only we got to do it for x and the y separate. If I want to find the x position, I got to integrate the x prime, the x velocity, from time 1 to time 2. And you remember this, I know you must have it. That will give you the x at position 2, or at time 2 minus the x position at time 1. And if they give you this, you write out this equation, and then you can find this one. If they tell you time 1, you know that position, you can find position at 2. Or if they don't tell you this one, if they tell you this one, you can plug it in and go find the other position. You can find either one, it doesn't make a difference. If I want a y, well, it's just the same problem again. We're going to have a y prime from t1, t2, and that's going to be the y position at t2 minus the y position at t1. Remember that this starts with the y prime and integrates back to the y. It's got to change. It's got to be the antiderivative. Otherwise, you're not going to know what you're doing. Okay, you got all these formulas. You got to memorize them. You got to know them. You got to be able to do them all. It is not hard. It's particle motion, but just in 2 dimensions. I'm going to make a formula sheet with all the formulas for this class, and you're going to memorize them because you're very good students and you're all going to pass the AP exam. Okay, goodbye.